Okay, so this is basically integration revision for the upcoming test. Now, what I first want you to do is a bit differentiation. So this is the function y, and f dash y means the y dx. So the y dx, we want to figure out what it is. So we're going to let u equal 2x and phi equal e to the x. So u is 2x. When we differentiate u, what we get is the number 2, because whatever is beside the x always chops off. Now, phi equals e to the x, so when we differentiate e to the x, it stays e to the x, and you usually differentiate whatever's in the power position. When you differentiate x, you get 1, so it's 1 e to the x, but that's the same thing as just e to the x. Now for the product rule, because we're going to have two numbers multiplied by u, or u multiplied by v, what we're going to say is u to v dx plus phi du dx. And what we're going to get here is we're going to get the y dx ends up to be u times the v dx, so it's going to be 2x u times the v dx, 2x e to the x, and then phi times the u dx, which is going to be 2 times e to the x. So there's your y dx, okay? Now it says, hence find the integral of 2x e to the x dx. Now what will often happen in these questions is your 2x e to the x will be present in your differentiate answer. So what we can do here is we can cross multiply up to dx. So what we're going to get is the y equals 2x e to the x plus 2 e to the x dx. Now before I proceed with this, the dx technically belongs to both of them. So before I proceed with this, I'm just going to remind you of a simpler question. If I asked you to integrate x squared plus 5 dx. Now what most people get for the answer to this is going to be a third x cubed plus 5x plus c. But we could have rewritten this question as the integral of x squared dx plus the integral of 5 dx, and we can see we get the same answer, a third x cubed plus 5x plus c. So we can see that we're allowed to treat the integral sign and the dx on both parts separately. So I'm going to do the same trick here. I'm going to treat the dx separately on both. So we're going to get the y equals 2x e to the x dx plus 2 e to the x dx. Now that I have that done, another thing that we need to be understanding is that when you integrate dx, so for example if I integrate a dx, integrating dx is the same thing as integrating 1 dx, which gives us an answer of x plus c. So what we're going to have here is we're asked to integrate, we want to find out what is the integral of 2x e to the x. So we want to get this 2x e to the x dx on its own. So we're going to move this over the other side. So we're going to get is the y minus 2x e to the x, so minus 2 e to the x dx equals 2x e to the x dx. Okay, and now what we're going to do once we reach this stage is we're going to integrate both sides. So when we integrate both sides, look what happens. Now our whole point is to find out what is this. Okay, so now we can see that this part here matches the question. Okay, so I'm just going to switch sides, and what we get is I'm finding out the integral of 2x e to the x dx ends up the integral of dy minus the integral of 2 e to the x dx. Now, like last time, when I integrate x, just dx or 1 dx, the answer is x. Vice versa, when I integrate 1 dy or dy, the answer is y. Now I'm going to integrate e to the x. When you integrate e to the x, you just get e to the x, and you're going to get, and the 2 goes straight down, so 2 e to the x, and you got to remember your c value. Now, what we also got to remember is what is y? Y is what we began the question with. Y equals 2x e to the x. So the answer therefore is going to be 2x e to the x minus 2 e to the x plus c. And that is the answer for the integral of 2x e to the x dx. Okay? So that's how we do these ones. So we'll try one more of them. Okay, so this is a similar trend as last time. You're going to get the derivative and then you're going to work backwards. So this time u is x, phi is sine x. So then we're going to get the u dx ends up to be equal to 1. And the v dx ends up to be cos x. So we're going to get this time is, we're going to differentiate it. Once again, I'm going to call this y. So now we're going to find out what the y dx is. The y dx is u times the v dx. So remember the product rule. U times the v dx plus v times the u dx. Okay, so u times the v dx is going to be x times cos x. Okay, and then it's going to be plus y times, or phi times the u dx, which is going to be plus sine x. Now, what we're going to do is what we did last time, is multiply up to the dx. So we're going to get the y equals x cos x plus sine x multiplied by dx. Now remember, that means you can treat both of them separately. So we get the y equals x cos x dx plus sine x dx. Look at your question. You're looking for x cos x dx on its own. And that's it there, your x cos x dx on its own. So move it over to your side. So we're going to get is dy minus sine x dx ends up to be x cos x dx. Now I'm going to switch the sides around. So I'm going to get x cos x dx ends up to be equal to dy minus sine x. Now I'm going to do next is sine x dx, that is. So what you're going to do next is going to integrate both sides. Integral sine here, integral sine here, integral sine here. And now look what happens here. So what we're going to get is, the whole point of the question is to find out what x cos x dx is. So the whole point is to find out what this is. So we're just going to integrate this side here. Now remember, when you integrate 1 dy, you're going to get y. If you're integrating 2 dy, you'd get 2y. Okay, so that's just the way that one works. And then we're going to integrate sine x. Okay. So when you integrate sine x, you're going to get the integral of minus cos x dx. Okay. Now when you multiply the minuses by each other, what you're going to get is a plus cos x. And remember y. Remember what y equals? Y equals x sine x. So it's going to be x sine x plus. When you integrate it, there's no integral sign, so excuse me, that was meant to be just brackets. So when you integrate sine x, it turns into minus cos x, and that dx is gone. And then you're going to get plus cos x. And don't forget your c. Plus c. Okay, so that's that next one done. Now, Qx is, we're going to go on to number, so we've done these two here, so we're going to go on to this one, number 26, okay? Now what this says is, get the derivative, differentiate x sine 3x, so basically you're saying is y equals x sine 3x, and you're going to differentiate it. You're going to say u equals x, phi equals sine 3x. Now we're going to differentiate this. So we're going to get is the u dx equals 1. Now the v dx is a chain rule, so when you differentiate sine 3x, you're going to get cos 3x. But what you also got to remember is to differentiate the angle, which is going to be 3 cos 3x. Okay. Now this is a product rule because it's u multiplied by v, so we're going to do the integral of. We're going to find out what is. We're going to use the product rule. Excuse me, plus phi times the u dx. So u is x, the v dx is sine 3 sine 3x, 3 sine cos, sorry, 3x times 3 cos 3x, and then plus phi times the u dx, which is going to be sine 3x multiplied by 1. We can get that out, it's going to be 3x cos 3x plus sine 3x. Now, we're looking to find out what 3x cos 3x is when we integrate it. Well, there's your 3x cos 3x right there. And like last time, we're just going to cross multiply it upwards. So we're going to get the y equals 3x cos 3x, cross multiply that dx upwards. And then we're going to get plus sine 3x over dx. Now multiply those dx's in. So we get the y equals 3x cos 3x dx plus sine 3x dx. Bring everything over to one side and isolate the, remember the whole point of the question is 3x cos 3x dx. And as you can see, it's located here. So what we're going to do is we're going to get the y minus sine 3x dx ends up to be 3x cos 3x dx. And I'm going to spin this around. I'm going to get 3x cos 3x dx ends up to be dy minus sine 3x dx. Now I'm going to put in my integral signs. Now this time, unlike the last time, we're going to have limits involved. Okay, and the limits we have involved are pi over 6 and 0. So pi over 6 and 0, pi over 6 and 0, pi over 6 and 0. So what's going to happen here is we don't have to integrate this part because this is the part that we actually want to know. So this is what we actually want to find out what it is, and we know that this is equal to what's on the right hand side of the equal sign. So it's going to be y integrated from pi over 6 to 0. Now remember what y is. Y is meant to be x sine 3x. So what we're going to do here is just rub this out. I'm just putting x sine 3x for y, because these limits are for x values only. Okay, that's because it says at the start that it's a dx question, so these limits are designed for dx only. And then we're going to take away the integral of this. Now when we integrate this, what we're going to get when we integrate sine, we're going to get minus cos. Okay, so that's currently a plus sign here, so it's going to be minus cos 3x. Now remember, we got to divide by the derivative of the angle all over 3, and that's going to be pi over 6 to 0. Now what we got to do is we got to integrate both of these separately. So this one here is going to be, if x is pi over 6, 3x is going to be pi over 2, or 3 pi over 6. Okay, so we're going to get is pi over 6 multiplied by sine pi over 2, take away 0 sine 0, 0 sine 0, so 0, and then we're going to take away this one here. When we take away this one here, what we're going to get is minus cos pi over 2 divided by 3, and then we're going to have a minus moment, because it's minus the second limit, cos 3x all over, cos 3x is basically cos, this time it's cos 0 over 3. Now the difference here is that, remember, sine 0 equals 0. Okay, so that's gone. And remember, sine pi over 2 in your calculator is 1. So this is just going to be pi over 6. Pi over 6, take away whatever is in here. Cos pi over 2, or cos 90 degrees, is 0. So we're going to have 0. And then we're going to have a minus, which makes it plus cos 0 over 3. Cos 0, when you put that into the calculator, is actually 1. So it's going to be pi over 6 minus a third.